Hello viewers, welcome to my channel Connect Civilians. So in this lecture we will see how to design a simply supported singly reinforced beam design as per IS code 456-2000 where the span length is greater than 10 meter. Okay, so here we are going to design the beam whose length is more than 10 meter. So these are the values that you have to provide, that is the thickness or bearing support width. So I will show you what is the support width. So this column C1 and C2 are two opposite supports and this is your beam. Okay, so here this is support 1 and this will be support 2. So this will be either a column for frame structure or a brickwork. Okay, so you have to provide the width of this brick or column. Okay, so this will be your width. So in our case our width of the beam or thickness of the bearing is 300. Okay, similarly for column 2 it is also 300, so just provide 300 for both the values. Okay, now we will go for clear span. So here we will take the clear span of 12 meter. Okay, live load is if you want to calculate the live load, here is the table for the calculation of the live load. So height of the floor, you have to provide the height of the floor that is coming above the beam. Okay, so here in our case it is 3.5, sorry, 3.2 meter, and here you have to provide the depth of the beam that is coming at the above floor. Okay, so that we can deduct the total height of the floor to the and depth of the beam. Okay, so we will get the clear height of the floor. So our beam depth is 300, that is above beam depth is 300, and if you don't know the value for this, so just take the value as 0 only. Okay, so I will also go with the value 0. Okay, and density of brick, so you have to provide the density of the brick here. Then in general case it is 10 and density of plaster is 22, that will be okay. But if you are using the lightweight bricks, so density may vary. So this is for lightweight bricks, and for red bricks the density may increases. Okay, so density of plaster is 22. Thickness of the block work is, in our case it is 150 mm. That is 6 inches, and the thickness of a plaster is 12 mm. So for outer we are going to take as 20 or 22, and inner we are going to take as 12. Okay, so total thickness of the plaster is 34 mm. Now our UDL acting on beam, it is calculated here, that is coming as 7.194. so this will be your live or imposed load. So this will come under the dead load. If you want to change the name, just you can change, but here we are going to provide in this, and it is coming as 7.194. Okay, so here in live load you have to put 7.194, take it as 7.5 for safety. Okay, FCK, so this will be your grade of concrete that you are using. So this I am going to take the grade as M25. Okay, and for FY main, so FY main will be generally the tensile strength of the steel. So for main bars it is, we are going to take as 500, and for shear we are going to take the tensile strength of the bar as Fe415. So what will be the main, so your brown bars are the main bars and your stirrups is the shear bars. Okay, this blue bar is your shear bars. and this will be diameter of the main reinforcement. So here we are first considered lesser dia. Just take it as 20 mm. We are going with 20 mm of dia for main reinforcement, and for dia bar for shear reinforcement we are going to take as 8, and if it will not pass then we will increase after the calculation. And factor of safety is 1.5. This will be okay. 1.5 is as per code. And width of the beam, so here again I will mention that you have to assume the width of the beam by yourself first. Okay, so here if you want to take the width of the beam as 300, that will be okay right now. And here it is simply supported. You have to select simply supported here. If you want to see the, if you select continuous and different conditions, that is simply supported continuous, to continue select the continuous, then it will only give you the span to effective depth ratio for continuous, but it will not design according to that. So this Excel sheet will only help you to design the simply supported beams. Okay, for continuous beam we will provide the video for that also in our upcoming lectures. Okay, so here you have to select the simply supported, and our span to depth ratio will be calculated. This black boxes, this value will be calculated by software only, and here your effective depth calculated is coming as 720. So you have to take the value higher than that. So now it is coming 720, so we are going with 725, and we have to take the effective cover, so we are going with 25. So what is the effective cover, I will also mention that. So the depth from the face of the beam to the mid of the bar, this brown bar. Okay, so this will be your effective cover. Okay, so here if you select the effective cover as 25, so in Excel sheet it will detect the diameter and your clear cover will be shown as 22. Okay, so if you want to increase the effective cover as 28, if you increase the effective cover as 28, so it will show you the clear cover. Okay, it will not changing the value, so I will change it right now. Okay, so this will be your clear cover as coming as 10 mm. So here you have to increase the effective cover as 50. Now we will see how much clear cover is coming. So clear cover is 32 mm. This will be okay. We will generally go with 25 mm for beam. Okay, so if you want to decrease, you can decrease the effective cover here. That will be depend on the condition of your atmosphere. You can check in ISCODE 456. So here this will be okay. Your total depth that is coming as 775. Our calculated depth is 720. This will be okay. Right now this is more. So now we will go for, so this, if you want to decrease up to 7, that's, so total depth will be coming as 750. So we will go right now with this. Self weight of beam is coming as 5.625. So total load, this will, here this will be added your dead load plus self weight, so it will coming at 13.9, sorry 13, and your ultimate load is coming as 19.69. So here your effective, in your effective span is coming as 12.3 for this, and design bending moment is coming at 372.32. Now design constant value, so this value will make changes according to the course. So here I will give an option to, if you want to change the value, otherwise as per IS code Indian Standards Code IS code 456, this will be okay. And your XU max value is coming at 0.456D. So your D calculated is coming at 612, and D what effective depth that we have provided is coming is 700. So this will be more here, so it will be safe in that boxes. This will show you safe, this will be okay, so we can now proceed. Okay, so if it will not show you safe, so you have to increase the effective depth. Okay, right now it is safe, so we will further proceed. So your limited bending moment is coming at 784.77, which is greater than design bending moment. So you this will be your under reinforced section, so it will be designed according to singly reinforced beam. Okay, if it will come as over reinforced section, so what you have to do, you have to again increase the depth or width of the beam. Okay, because this Excel sheet only used for the design of singly reinforced section. And what is singly reinforced section? I will again repeat. In singly reinforced section, only the tension in tension area the steel will be designed. At the top, you don't design the according to your compression zone. Okay, this 2 bar is provided just to support your stirrups. Okay, only for in tension zone it will be designed. So this will be singly reinforced. So it will always come as under reinforced section. Okay, so you have to again increase the depth. We will also talk about the doubly reinforced in our upcoming lectures. So right now this will be okay. So your main reinforcement will be calculated as 1414 mm square, and your ST minimum for tension zone is coming as 357. So this will be, and maximum value is coming as 9000 mm square. Okay, so area of steel provided for bar that we have taken is coming as 314 for 20 mm of bar. So number of bar required is coming as 5. So just go here, you have to number of bar provided, you have to fill by yourself. I am going with 5 only, that what we have calculated. So 5 will be safe. Okay, if you decrease the bar, see here we have decreased the bar to 4, so it will show you not safe, set the number of bar again. So these two boxes you have to check either it is showing you safe or not safe. Okay, so here you have to take it as 5. This will both the boxes are safe, so we will further proceed. So your reinforcement is calculated, and we have to provide the 5 number of bar of 20 mm dia, and here it will show you the calculation for shear reinforcement. So this value will be calculated here, and for nominal factored shear force is coming at 121.08 kilonewton. Nominal shear force is coming at 0.58, and percent of tensile reinforcement is coming at 0.748. So design shear strength will be calculated by from IS code 456 2000. Here the interpolation table will be used for the calculation. So I will give you the from where we have taken for the this value from table number 19. You have to check. Okay, so this will be table number 19 on page number 73 on IS code 456 2000. From here you have to design your shear bars. So here you have to provide the percent tension reinforcement. So this value will be taken by itself, 0.748, 0.75. This will be same here, and you have to check the grade of concrete that you have taken earlier. So we have taken M25 grade of concrete. So from ISCO 456 you have to check 0.75 is coming in between which option. So 0.75 is here, so lesser value is 0.5 and 1, and greater value is 1. So 0.5 and 1 we have to take. So 0.5 you have to provide here, and 1 will be here. This will be okay. and for M25 grade of concrete we have to go 0.75 and M25, so you have to take 0.57 and 0.64. okay, for one it is 0.64, so 0.57 and 0.64, here you have to provide 0.57 and 0.64. okay, now your design shear strength is calculated 0.6 and here it is taken by itself. Here see here 0.6, so this value will be taken here. So now shear is here, so what will happen, your design shear strength is more than your nominal shear strength, so this will here it will show you shear reinforcement not required, but you have to provide the minimum shear strength. Okay, sorry, minimum shear bars. Okay, so we will provide the minimum shear bar here. So we are going to take the dia of the shear bar as 8 mm. So here we have taken already taken 8 mm. So if you want to decrease the dia of bar at 6 you can, but I am going with 8 mm here. So here we have taken 8 mm of dia of bar of 2 leg stirrup. So what is 2 leg, I will show you in figure. This will be your 2 leg stirrup. Generally we will provide this. This will be one leg and this will be second leg. Okay, so you have to provide the 2 leg. If you want to increase the leg, so you can also do that. Okay, so this figure will give you general overview how your beam and what is provided for stirrups and main bars, and if you want to increase the leg you can here. Okay, but right now we are going with 2 leg. So area of bar we have provided as coming as 100.48 mm square for stirrups, and spacing of stirrup is coming in negative because in our design it is not required, but you have to still provide the minimum shear reinforcement. So minimum spacing is coming as per code as 302 and maximum is coming as per code as 300. Okay, yes, so if you want to see you have to put the cursor here and it will show you the cloth number 26.5.1.5 on page number 47 in ISCODE 456/2000. Similarly for here also you can check. Okay, so all the boxes I will already mention the clause from ISCODE 456 from where we have taken. Okay, here, so this will be okay here. So we are going to provide 8 mm of bar of 2 leg at 300 mm of center to center spacing. Okay, so minimum maximum spacing that is allowed will be for step is 300. Okay, so and at support if you want to decrease the spacing you can go up to 100 mm. Okay, some code will also guide you to provide to decrease the spacing of stirrups up to 100 mm and you can go to 300 mm. Okay, maximum spacing, but more than 300 mm you can't increase the spacing more than 300 mm for stirrups. Okay, so this here will be your deflection check also. So percent of tension inform is coming at 0.748. Your fs value will be 261.12. so from IS code 456 only we have to taken from the table. I will show you. Okay, on page number 38 this will be a modification factor for tension reinforcement. So this will give you the overview. So what value we have coming, so percent of tension reinforcement is coming at 0.748 and our fs value is coming at 261.12. so this will be our fs, so 261.12 will come between 240 and 290. Okay, so it will come around here and our percentage is 0.748. so 0.748 will come between 0.4 and 0.8. Okay, so 0.74 will come around here, so we will go straight here and our 261 value will come nearby this, so we can take up to 1. Okay, it will come nearby 1 only. Okay, this will be your graph. Okay, yeah, this will be correct, and your value will come nearby 1 or 1.1. Okay, so we will take the value as 1.1. Okay, we have already taken, so this will be okay. So our L by D provided is 17.54 and our L by D maximum is coming as 18.33. So it is real, so it is safe in deflection. So if this value will less than this, so you have to, if you will check here, 0.5 is provided for your, so it will show you not safe in deflection. You have to again increase or decrease the increase the width or depth of the beam. Okay, but here as per code we have already safe. Okay, so we have done the calculation procedure for the design of the singly reinforced beam, where the span of the beam is greater than 10 meter. So this is simply supported singly reinforced beam. This figure will show you the stirrup that we have provided, the 8 mm dia or bar or two-legged stirrup at 300 mm spacing, and here it will show you the clear cover, the total depth and width of the beam, and the number of support bar that we have provided to support our shear. Okay, so this will here you have to provide the minimum number of bars. So we have calculated EST minimum for tension zone in beam. Okay, so it will coming at 354. So if you want to check for from your side, just you can also check from here. Just change the dia bar as 8, and here what you have to do, sorry, so 20 mm, this will be okay. And here if you provide 2 mm of bar of 20 mm at the top to support the uh, shear stirrups, so our area is coming at 628, which is much greater than your minimum reinforcement. So this will be okay. So you can also provide that 12 mm of bar. Okay, here see, if you provide 12 mm of bar, this will also be okay. Okay, so this bar is only to support your stirrups at the top also. Okay, so you can provide according to you. Either you want to provide 2 mm of 16 mm, you can provide, or 12 mm you can also provide. Okay, and other value will be calculated by this Excel sheet. You don't have to change any values in this. All you need to do, you have to just design according to you, and here it will show you what your bar you have to provide for main, and what will be the dia bar of your main reinforcement. And after designing this, your shear step, you have to take the only change the blue box value, that is 2 legged or 4 leg, what shear bars we have to provide. If you are going with 2 leg, you have to provide 2. If you are going with 4 leg, you have to provide 4. Okay, so I hope you know what is 2 leg and 4 leg stirrups. If you don't know, you can comment me, I will make another separate lecture for that. Okay, but generally 2 leg stirrup will be provided. This will be a 2 leg 1 and 2 leg. Okay, so I am going with that only. So here you have to only change this 2, and after all the steps it will show you either it is okay or not. So we provide 8 mm dia bar, 2 leg, 300 center to center, and here it will be a deflection check. So this red box you have to check either it is safe or it is according to your design or not. It will show you safe in deflection, and it will show you under reinforced section. I will again repeat, if it will show you over reinforced section, you have to increase the width or depth of the beam. Okay, if you are going with singly reinforced beam design, either or you can design for doubly. We will talk in another lecture for that. Here only we are going to design the singly reinforced beam. So you have to change the value in blue boxes only, and other value will be calculated by itself. And bar that is required is coming as 5, so you can again increase or decrease the bar according to you. Either you, if you want to provide the number of bar as 6, you can also go. Okay, 5 will also be safe, that will be okay, that was not a problem. But if you go with 4 number of bar, it will show you not safe, so you have to minimum go with 5. This will be also okay. And if you want to increase the bar, if any value will not safe here, okay, so you can also increase the number of bar here in place of increasing the depth or width of the beam. Okay, but you have to remember that you don't have been allowed to go below the maximum tension reinforcement. Okay, just I want to show you here. I will show you. If you provide 1 minute, 20, 35, sorry, I will show you what I was trying to say. So here, see, if you have provided 35 number of bars, this is only the assumption that we are providing 35 number of bars. This is practically it is not possible. But if you by mistake you have provided 35 number of bars, so this box will show you not safe. Okay, because you have already gone um, uh, more than your maximum tension reinforcement, that is coming at 9000, and our bar provided area is coming as 10,990, so this will not be okay. So you have to set these both boxes as safe. Okay, this will be here safe. Okay, so here it will also show you in that box, it will show you shear reinforcement not required, but still you have to provide the minimum shear reinforcement. And here in which clause it is mentioned, I will already provide a clause 40.4 on page number 72 from ISCODE only 456. Okay, and this will be your interpolation table. Okay, only the blue boxes you have to change, and other value will be changes by itself, and all the dia and for main and stirrup will be calculated here. And you can see the figure here if you confuse how the bar will be taken. Okay, so I will provide both the excel sheet, that is protected and unprotected. You can download it. Okay, and what will be the protected? So in protected sheet, what you can do, you can only change the values in blue boxes, and other value will be changed by itself. You can't see the able to check the or change the formula according to you. And if you want to download the total unprotected sheet also, so you can copy and change the formula or method according to you, the minimum and maximum reinforcement formula according to you. So you can download the unprotected sheet also, so you can also manage according to you. But for as per IS code 456, this sheet will help you to design the single reinforced beam. So if you like this video, please subscribe to my channel. Thank you.